Welcome back everyone to another SDS2.NET API tutorial. In this tutorial we'll be covering transactions. There are two types of transactions. You have read and write. Now if you've been following along with our tutorial series, you might be thinking, hey, I've been able to query for my model and I haven't needed a transaction. Well, you're right, but there are two types of read transaction. That's implicit, that requires no setup whatsoever. Then you have read transaction that require a little bit of setup. You might be thinking to yourself, why would I want to write extra code just to read from my model? Well, when you do, and depending on your use case, you get a massive performance increase. But don't take my word on it, let's jump into Visual Studio and see for ourselves.
Our benchmarking test is pretty straightforward to test the effectiveness of a read-only transaction. So I have a method called processJob, and inside of here we get all of our members, then we get the brief of a member and we just read one of the properties off. So we do this one time without a read-only transaction, one time inside of a read-only transaction. So before we hit the test, the syntax of a read-only transaction is you'll need to have a using statement, read-only transaction, variable name equals read-only transaction, and you pass in your job. And then I do some math here at the bottom so that way we can see what the percentage increase or decrease is in time. So with that, let's start. So as we can see here, we actually had a 99% decrease in the amount of time it took to read. Now I find on average you get somewhere between 94 and 99%. It makes quite the difference. Now you might be wondering why a read-only transaction saves us so much time. When you are reading properties from an SDS2 model without a read-only transaction, and you are reading multiple properties from an object, SDS2 will go out and get updates from the database per property that you are reading. Versus in a read-only transaction, you can read an unlimited amount of properties, and SDS2 will only get updates when it deems it needs to. So let's move on over to write transactions. So I have a method called updateDrawings, and inside of here we have a lot of transactional code, but the idea is that we're just going to get all of our detailed drawings. We're going to update one property and write that back to our database. A write transaction looks a lot like a read-only transaction, except for there's a different object type. We have a transaction instead, and it takes in two parameters. One is the job, and one is an iLock handler. So in this case, we're using the immediate lock handler. That means it's going to try to get a lock, and if it can't, it will fail immediately, and it fails silently. The other default iLock handler is called the interactive lock handler, and that will pop up some UI saying, hey, we can't get a lock in these objects, and this is why. So if we go through the rest of my code, we for each through our drawing handles, we get a drawing, we add our drawing to the transaction, then we lock our transaction. Now, in production code, you should probably add all the objects to your transaction before locking them. But for this test case, we're just doing one at a time. Another note is that you generally want to call transaction.commit once per transaction. You can call it multiple times, but it causes a lot of extra locking to occur. So just keep that in mind. We then will, after we update a property, we will then call transaction.commit, and that returns a transaction failure. And that can be implicitly casted to a boolean, so that way we can see if it succeeded or not, and if it did fail, we can get the reason for why it did fail. Alright, so if we go ahead, say run transactions, we'll first see our very first code, then I'll hit enter, and we'll see a bunch of transactions starting to get committed. This is really good. Now let's see what happens when we have objects that I have the immediate lock handle in place, so that we should see them fail instantly. So I'm going to go ahead and run my locker app, and all this does is it goes through and it locks all the drawings. Then I'm going to start my transactions. So we see saving 97% there, and bam, that was really fast. All of our transactions failed. So that is exactly what we were expecting. Earlier I said that write transactions take in an iLock handler. Well, this happens to be an interface that we can implement our own type of lock handlers. So I have my own custom lock handler. So the iLock handler interface has 3 methods that you need to implement: the event loop that returns Boolean, locked failed, and locked succeeded. So the meat and potatoes of this interface is the event loop. So the event loop gets called every single time that SDS2 wants to check if it should keep trying to get a lock. If you return true, you're telling SDS2, yes, try to get another lock, please. If you return false, it will abandon to get a lock on that object and it'll move on to the next one. So if I expand, so my custom lock handler is we pass in amount of seconds to wait, and then it will attempt to get a lock for that amount of seconds. So if it's the very first attempt, we assign the date time. Otherwise, we look at the amount of seconds that has passed since our first attempt. And if it's less than or equal to 2 seconds wait, then we'll keep trying. If we are past the amount of time that we're trying to lock an object, we will reset the first attempt and return false. The reason why we would want to reset it is if we're doing a locking some type of loop, that the next time it calls lock, it's going to reuse this object. So if this is already false, it'll be false for the next time. So if we go back to Program CS, I'm going to change my immediate lock handler to my custom lock handler, and then I'm going to pass in 3 seconds. So we should see some fails and some successes. I'll start transactions. So we can see we saved 97%. See, we had 1 locked fail, so that one took a little longer than 3 seconds. We had another one, and perfect. That is exactly what we were expecting to see.
Now that we've learned how to make updates to SDS2 and how to speed up our reads, we can really start writing some useful applications. Thank you so much for tuning in with us today, and until next time, I hope you have a wonderful rest of your day. Goodbye.